Good morning, everyone. I'm still learning my British accent. Greetings from Finland. And first of all, thank you, Scanware. I've been talking with a lot of people yesterday, this morning. I only hear good stories about this event. Keep on going, Team Scanware. This is great. This is just great. Thank you. Nice to see your own face. Quickly, I've been working 20 years with arc flash protection systems. Every major brand, big brands globally, every industry, from offshore to land, from nuclear to wind. So I've been working 20 years, or actually as an engineer, more accurate, 19 years and 363 days, 4.5 hours about. So, yeah. I started dramatically after fatal accident. Fatal arc flash where 2 engineers died. Imagine that there was a 6.6 kV breaker about here, 2 engineers working here, and there was a wooden door and the phone where the third guy was calling to the control room that we are about to close the breaker now. And this door exploded outside and this third guy was burned. He was the only one who survived. And I went there as a student. Still, I was studying arc flash phenomena, arc flash pressure. And I went there and we built a prototype arc protection system. And that unit in that power plant, since after 20 years, it has never been started again. So that tells do we need arc flash protection? For me, it was very, very clear. Does these things happen in nuclear plants? Of course. Do you read it from newspapers? No. Do you like to read it from newspapers? Probably not. Does these things happen in fully insulated arc-resistant switchgears? Of course. Unfortunately, it's possible. Human errors, equipment failures, lack of maintenance. Is the maintenance cost? For someone, it can be a cost, but that cost will be much, much more expensive if it's lacking. Loose connections, animals like rats, for example. If you have power plant, you have cooling water. If you have cooling water, you may have rats. And that happens. So here, before and after, this is quite self-explanatory. You cannot use the switchgear on the right-hand side anymore. Yesterday, there was a lot of talking about incident energy. Somebody asked calories. Why calories? Why don't joules? Calories per centimeter square. Why do we use that? Well, the calculation is fairly simple if we simplify it a lot. So it's the duration of the fault times the magnitude of the fault and this square. This is simplified very much. It's very difficult to get lower level of the magnitude. It's fairly easy to get rid of the duration. And that's long clearing times, it's higher energy releases, more damage and stress, which is higher risk. Significant developments have been done during the years. There used to be concrete panels, just walls between the different cubicles, and fully open bus bars like Marcin showed yesterday. And they still exist all over the world. You can touch the bus bars. You sometimes have to crawl under it because they are so low. And live coppers, you can see it. They are painted yellow, red, probably purple, green. They are painted, but they are very dangerous. And the biggest one I have seen has been in one room, 150 megawatts in the live bus bars, and you can touch those all. Sounds crazy, but that is how it was in 1950s. Big steel plant, that was the way how they built, and they still works. So you can still reduce the duration. Incident energy calculation, arc resistant testing, testing according, for example, IEC 641. Personal protective equipment, very important. That has been probably the best development what has happened since when I started 20 years ago. Arc detection relays, it's not a new thing. First arc detection relays was built 1970s. Nobody just knew it. Some of the relays were built hidden, secretly. Don't tell your boss, but I'm building something like this. Don't tell your boss, might be angry. Arc fencing device, it's not a new thing. It's also almost 20 years. It's actually more than 20 years old invention. There are 3 steps you have to detect. If there's an arc fault, arc flash, you have to detect. Then you should, after detection, you should protect. And then you can also mitigate the fault. There are different technologies, different detection methods like light, optical light, like it was mentioned in a man from Schneider mentioned that light and current, it's like a logical AND gate. Light and current, and it can be also pressure, it can be voltage. The pressure is equally good, it's equally fast, but actually the phenomenon of the pressure, when there is a light first, then there is about 6 to 7 millisecond delay before the pressure peaks up. 6 to 7 milliseconds, that is quite accurate. And then there are different technologies like a point sensor and fiber loop sensors. Fiber loop sensors typically up to 50 meters, and plastic and glass cores. For the protection, you need the detection. And for the protection, you need proper wiring. Wiring has to be correct. Circuit breaker has to be well maintained, good condition. It has to be tested. If you have 120 sensors, do not test your breaker 120 times. It will break this. In the end, it will do the bad thing for the circuit breaker. So it's not the intention, but to do proper testing from the system, that the system works. And here is just an example. This is a feeder selective example. Sorry, I will turn a little bit. So there are, for example, this feeder selective point sensor in each cubicle, in each closed compartment. For example, here, cable termination here, circuit breaker, and a bus bar. And feeder selective means that if you have fault in this cable, intention is to trip only that breaker. And if you have the fault above, you trip the main breaker and upstream. If you have tie breaker and a bus A, bus B, or main tie main, like they say it in many main tie main, you also trip the tie breaker, of course. Mitigation technologies. These ones here, left side is a low voltage, 690 volts. Resettable, it can be tested. So it can be tested 100 times. So if you do it every 5 years, I still don't promise that it will last 500 years. But you can really test it. So it kind of works like a car airbag, that when you have flash, for example, there, this arc fencing closes close to the main breaker and absorbs the arc flash energy into the arc fencing device. Meanwhile, simultaneously, the breaker is being tripped. And similar to the medium voltage or high voltage, up to 24 kilovolts. And one installation example, directly bolted to the bus bars. Hopefully I didn't break it. This is a test, 30 kiloamps test done in Berlin according IEEE TS 63107. That was released 28th of April 2020. So in last 4 years, there has been 3 new standards what comes to the arc flash mitigation and quenching technologies. So this was the lowest amount of power. In this test, we practically lost all the coppers from this cubicle. They vaporized. And now this is something interesting. So left side, this is a fully identical, fully synchronized video. Left side, you can see 30 kiloamps, 730 volts arc flash. It's simulation of the feeder protection upstream. The middle one, again fully synchronized, high speed, 1000 frames per second. This is an arc flash protection with the circuit breaker opening. And the right corner here, right side, it's the arc quenching device. So have a look on this one because it goes quite fast. So again, high speed, 1000 frames per second. And yeah, looks like that the left side is just about to start. So it will last quite long, so I will skip to the next one. So it keeps burning until the coppers are gone and vaporized. So I will skip to the next one to save a little bit time if it goes to the next one. It did. So this is how it looks. This is 30 kiloamps now. Have a look on this second from the bottom. This is how the arc flash looks like from the transformer point of view. It's a lot of distortion. When you burn copper, when you burn electrode, it is changing, the impedance of the fault is changing all the time. So arc flash looks like this. This is 30 kiloamps until you have the third cycle full and the circuit breaker is completely open. Did you know that actually you have two arc flash here? You have the arc flash and you have the circuit breaker arc flash. Always when you open the breaker, you have an arc flash. That's how it goes. This is more than double amount of current, 65 kiloamps. This is how it looks from the transformer end when the arc quenching closes. First peak here is the arc quenching closing and absorbing all the current. So this is when we already have mitigated the fault. The actual fault has been already been shut down. And what is the next peak? It's the breaker opening. So there will be another peak, and the total amount of energy, accumulated energy, is 300 kilowatts in this fault. And we can compare, I will skip to the last one here. So we can compare it to this one. Left side, same fault with the arc quenching, and same fault without arc quenching. So 5 megawatts instead of 300 kilowatts. So this is kind of give the idea how arc quenching works. Fault here, quenching here, absorbing everything here. And final slide, or two final slides. Next slide, there's another visual here. So I wrote a paper, I was authoring a paper which is now released or published in IEEE magazine called Safety Beyond the Standards, Doors Wide Open. So here is a test in the next video where we tested 65 kiloamps doors open to simulate how arc quenching works. And that's it. So we had the arc flash ignited here, and then this happened. And we still have that panel in our warehouse because I'm planning to go back to the laboratory to do some more testing because it's actually quite fun. So thank you for listening, and any questions, then I have time, my flight leaves Friday, so thank you. And cheers.
Good morning. I'm Ian Hodkinson from ABB in the UK. Firstly, thanks to Scanware for this conference. It's a fantastic opportunity for everyone to get together and discuss these important topics. Secondly, thank you to Mikko for reminding us all about what an arc flash is and how important and to protect against that. So I'm not going to tell you what he's just told you about the arc flash because he's done a great job of explaining that. But what I'll try and do in my bit of time is to quickly just breeze you through the products and solutions that ABB has for protecting you from arc flash incidents. Okay, so first of all, as you're aware, and we've mentioned it yesterday as well, you need to design in arc protection into your switchgear. So we call that passive protection. So if your switchgear is designed to internally contain that arc, that's a positive in the first direction, and that's in your design stages. Secondly, you can take steps to mitigate by using active protection to reduce the energy levels and take that step further and to reduce that time to get that arc cleared. And then further, you can put preventative measures in place which will obviously help you to avoid that arc incident in the first place. So just to put you in a picture of where we are in ABB, we're obviously kit all over the distribution levels, and you can imagine we're coming down from the high voltages, from the transformer side, from the HV to the MV, whether you get your first distribution switchgear. And then of course we are also active, and we have portfolio in the MV distribution and MV LV substations. And then right down to the LV distribution into your industrial sites, into your houses, residential areas and commercial areas. Across all those areas we'll have switchgear, whether it be ABB or any other vendor, and of course it's important to have protection both designed into that switchgear but also with active measures. So just to, as I say, breeze you through what we have in our portfolio, and we have a booth just upstairs which probably many of you have noticed, and you can just come and talk to us and ask us questions if you are interested in finding any more information on those. So we have LV products. Again, it's important, and I guess you will all have gone through this, in the design nowadays we talk about internally arc-rated switchgear. There are IEC and IEEE standards. We are type tested and designed to those rigorously, both in our LV and our MV products. We have LV products which cover up to sort of 430 volts and up to 690 volts, but we also have a motor control center switchgear as well. And in your MV product range, we have a wide range of 11, 24, 36 kV, AIS, GIS, and ring main units, primary and secondary distribution switchgears. All of those are designed and rigorously tested, so they have a robust design. They also have compartmentalized segments and chambers within that, so it separates the areas so that any arc can be contained. And then the other design point is that we normally would vent or try to design within the switchgear a passage for if there is an internal arc, your preferred path to take any of those exhaust gases from that energy and the plasma, and we can then get those evacuated out through maybe a chimney or a flap and duct that out into a safe environment away from the operators. So these are very important steps when you're selecting your switchgear, but also we take it when we're designing and selling these products. Then we move on to the active protection you can have in our portfolio, and like Mikko very well demonstrated, you can see the energy surges up, but the thing that hits first and foremost is the light, because light is the fastest speed of light, as we always say. So if you can detect the light, you'll detect it very, very early, and that enables you then to act and detect. Once you've detected the arc, you can then act on that arc and employ the protection. And the important thing is to try and get that time for the clearance as quick as possible. As soon as the lower you get that down, the quicker it moves, the less energy you're exposing the board, and therefore the personnel, and the less risk to you damaging your assets. These are the key points which I think have been mentioned already this morning. Safety for personnel, safety for your assets, and keeping the lights on. Okay, so in terms of keeping that time down, we have various different methods. I think we talked from Schneider earlier, very, very similar, and on Arcteq as well. It's about utilising different methods, and we have optical is always a very good one because of the light speed, but it's always good to back that up with current so that you don't get any malops from maybe a light that isn't an arc protection. Although it is quite important to say that an arc, the intensity of an arc light is completely different from just a normal daylight or torchlight. If you use a high intensity, and a lot of the devices, you can set the intensity setting up to really high so that it will only be detecting an arc and nothing more. And always a good measure is that wherever you've got a light that's from an arc, you will guaranteed, if it is a genuine arc, you will get a very high surge of current very shortly afterwards. So this current and light is always a good guarantee of detection. And we have a number of devices. We have here ArcGuard, which is used in our low voltage switchgear, usually because it's got multiple sensors, point sensors, which you can get, as you can imagine with low voltage switchgear. There are a lot of drawers, a lot of compartments, so that's really good to get complete coverage of the board. And again, that can be combined with current and a separate module. We also have a standalone system, which is the RAYA. This is a combination of centralized units and extension units, so you can have full coverage. This is perhaps what we'd say is good for a new board, but also good to retrofit because you can add it on top of your existing protection, especially if you're worried about your outages being too long without having to fully replace everything. You can just add it on top of your existing protection. Don't touch the grading, don't touch the relays, your scheme when you're wiring. It's just an addition for doing arc protection only. However, we do have, in a lot of our new builds, we always have this now, is a lot of customers are saying, well, let's just do arc protection from day one. It's a very small and insignificant cost. You're going to be fitting protection relays, and most modern protection relays nowadays, especially ours in the Relion family, have integrated arc protection, and you could do that over Ethernet comms, so it's the fastest communications between unit to unit, incomers to feeders or feeders to incomers, to break and to sectionalize and to be clever in how you do your tripping for the board. We also have now what we call a centralized protection and control system. This is pretty much not specifically to arc protection, it's just a nice new way of doing this. So we have merging units instead of protection relays in each individual panel, and we have one protection device or one server with all the protection functions housed within, but the merging units do the detection of the arc, send the signal over Goose to the centralized protection. The protection, if it picks up the current and it decides in your logic which feeders you want to open, close, whatever, and how you operate your switchgear, then that message is sent back very quickly over Goose back to the merging unit to do the tripping command. So I just thought I'd make you aware of that, and again, there's a lot of detail to cover in just a single slide in a few seconds, but if you're interested, please come and talk to us about that. Some of the other devices, methods we're talking about is Mikko touched on, is quenching. This is sort of quenching, but it's maybe more redirecting the arc flash, which is our UFES, is the ultra-fast earthing switch. So we normally use this in combination with a arc protection or arc detection system. The arc detection system can operate and pick up in 1 or 2 milliseconds, and it's normally the breaker that takes the additional time, because we're usually tripping a breaker, which most medium voltage breakers 40, 50 milliseconds, or low voltage 60, 70 milliseconds. So that's your total clearance time. This enables you, if you've got a very high incident energy level on your board, you can get full clearance of your arc in 4 milliseconds. So 1 or 2 milliseconds to detect it, and this is where it sends a signal to the UFES. It acts very quick on an airbag technology, shoots the rod up and makes the connection and takes the full energy of the arc down to the earth, and that clears in just another 2 milliseconds. So full 4 millisecond clearance time, and then your breaker can happily just do its trip in its own due diligence time. But that's just to isolate the system. Okay, so then we talk finally about the preventative methods. So there's many different ways, and I think we touched on one in the last section as well. There's remote switching is always a good one, and to help with remote switching, we recommend using sort of like a remote operating panel that's maybe not in the same room as the switchboard, but maybe in the room next door, or even you go a step further and it can be at the control center over communications to your site-wide SCADA. But this example we have on here is just a very, very simple remote operating panel. It's a touch panel PC in a cabinet, nicely wired up, simple connection, communications cable from the switchboard and all the protection relays into the panel. You can see and visualize your full switch gear in a single line. On the screen, you can touch, you can zoom in, you can control, you can operate, you can see the events, you can take the disturbance records, you can do whatever you like with the protection relays in terms of changing settings. But the most important thing is you're away from the switchboard. So again, this is a good preventative action. Other methods we have, as we talked about, is maybe doing remote stuff. So again, we've got remote racking capabilities in both our MV and LV products. So on top of the remote switching, we have remote racking, which is possible to have. And my final slide, just to conclude on the preventative solutions, is it's also an important point is maybe you are aware of your condition of your equipment. So we have lots of different condition monitoring methods you can put in place now. We have a SWICOM, which is connecting to multiple sensors. So we have partial discharge, we have temperature sensors, and those can be located in different parts and locations within the switchboard on each individual breaker, the cables, and on the busbar chambers. Then this helps you to monitor and detect the levels of the health of that switchboard. And again, that can help you to then have condition-based maintenance rather than just time-based maintenance. And that will help you to highlight any hot spots or any issues with your switchboard, and again, to help prevent any major incidents. Combined with the protection relays that we have nowadays, where they have all of the information for the breaker, such as the switching and the timings, and a number of operations, all that information can be brought back in with the sensors over the comms into the SWICOM, which could then be taken remotely away. So thank you very much for your time. If you've got any questions, we are upstairs. We're here for the rest of the day. Just come and have a chat, take our details, and we'll speak to you soon.
Daniel Furbush, and I'm the president and CEO, co-founder, and patent holder of autoLOTO. It's a brand new digital innovation for lockout-tagout software, and many of you probably haven't even heard of us. We've only been around for around 18 months, and mostly in the data center industry in North America. So we started with a simple premise saying, okay, we've seen essentially innovation stagnate in the electrical lockout-tagout safety space, and we've seen electrical incidents kind of stagnate in North America. So how can we kind of address this? And we started with every single one of us in this room has a supercomputer in their pocket. So how can we leverage tools that we use every day and bring lockout, tagout, and the power of cloud computing, the Internet of Things, and deploy that on a tool that everybody has in a meaningful way to protect people and to increase efficiency? And we coined a new term called personal protective software instead of personal protective equipment. And we're just going to run through this quick agenda right here. And we're going to introduce what autoLOTO is. So autoLOTO was defined by the mission of removing human error from the lockout-tagout space. That's where we started. And as you can see, defined in our mission, we needed to find a way to not only make that more efficient, but also to eliminate that number one root cause, which is causing the majority of our lockout-tagout incidents, injuries, and unfortunately electrocutions. And what we did is we broke down our digital application into two independent spaces. A cloud-based encrypted URL, what we call our worksite manager, which is designed to create a digital twin technology that can map every single bus, every single circuit breaker, and every single power path in your facility or project from your utility input all the way down to your smallest end-of-line 20-amp circuit breaker. And once that digital twin is created, we can instantaneously create compliant lockout, tagout isolation plans for your teams. And by instantaneously, I mean in 1 to 5 seconds. our software can read through and identify every single power pathway that is going to potentially put your workers at risk when they break the plane and go into those pieces of equipment that they need to maintain or isolate for your facility or project. We then combine that with a mobile application that has a real-time feedback loop that can actually validate the intent of your operators before they perform an action. And what that does is we can actually insert ourselves into what we call the OODA loop: observe, orient, decide, act. And we can actually influence behavior before an action takes place. So our application can actually provide real-time feedback to that operator that says, hey, the action that you think you're doing is going to put you at risk. The action you think you're supposed to be doing is going to bring your facility with an unexpected downtime event. So this is what we've done over the last 18 months since we brought autoLOTO to market in the North American data center market. We've deployed autoLOTO to more than 1.2 gigawatts of data center construction and operation projects, more than 25 capital construction projects, more than $15 billion in North America and now globally with some of our projects that are now in Malaysia, Hong Kong, Australia, France, and obviously North America. All of our clients that are using our product, we have 0 lockout-tagout incidents across more than 20 capital construction and 5 operational data center projects. 0 facility downtime events due to human error-based lockout-tagout. That's not a statistical anomaly. That's the power of our OODA loop system that can essentially input and validate intention before operator action. We've saved hundreds of thousands of work hours, tens of millions of dollars on our construction and operational projects, and we've returned our clients a greater than 10-to-1 ROI utilizing our software. So how did we achieve 0? And I'm not going to guarantee 0, but we do guarantee a 99% reduction. But so far, we're batting 1,000, right? But how do we do that? Well, we lean into the human condition, right? A lot of us in this room have thought about and created procedures to tackle specific events that happen. And what ends up happening is we add another procedure, we add another procedure, we add another procedure, and eventually, in reality, we end up smothering our operators, right? We had a great story yesterday about a near miss where the operators decided we're going to do all of our paperwork beforehand and then we're going to execute our work because they were more worried about their schedule and their timeline in order to do that switching evolution than they were about doing it by the book, right? And what autoLOTO does is we build into the human condition. As humans, we want to get to the end goal as quickly and efficiently as possible. So if we build and put documentation and procedures and paper in the place of that goal, we're never going to be able to solve the edge cases of human response. So what we found is we need 3 things for new technology to be adopted. The first is it needs to be less expensive or it needs to provide something more effective to the client, right? The second portion is it needs to be safer than the existing system that you're currently using. And the third and most important is it needs to make the life of your operator and your electrician easier. And if it doesn't involve all 3 of those items, it probably isn't going to be adopted. And fortunately, we've been able to prove that with our 1.2 gigawatts of successful construction projects. More than 10,000 electricians have been protected by our software. And we've been able to actually calculate that we've stopped more than 350 near miss or potential injuries through our software because we can actually track negative inputs into our software. So this is what it kind of looks like for our solution. Basically, we take a highly digitized version of the digital twin that can track every single hazardous energy flow throughout your facility or your project. We combine that with our patented single pass-fail phase gate system that says, hey, if you don't do step 1 correctly, you don't get to go to step 2. And if you do step 2 correctly, you then get to move to step 3. And if you do step 3 correctly, you then get to move to step 4. We've taken the best practices of more than 700 electricians around the world, and we've created essentially our patented lockout-tagout process that has returned 0 lockout-tagout incidents across more than $15 billion of capital construction and operational data center projects. as we're doing this, it automatically compiles all of your compliance and your paperwork. It's all digital. There is no paper process in the autoLOTO system, so for all of the sustainability bean counters out there, you can say, hey, we're doing away with all that extra paper. And then finally, the last portion is we're a safety by design and a personal protective safety software company. So essentially what we can do is we can build these digital twins, especially in the construction phases of our clients. We can do it in the design phase, and we can do it with the subject matter experts when they have more head space to be able to work with us prior to commissioning and energization when they're running around like crazy, putting in 16, 18, 20-hour days. With the existing systems, you're asking them to not only make their biggest decisions in the craziest parts of their schedule that have the largest impact and the largest risk on your projects, especially in construction. And if we can take their experience and we can build it into our digital twin when they are less stressed, have better sleep, then we're going to be able to provide that experience and that information through our application to everybody on these projects and just move that stress level a little back. So this is what going digital looks like compared to your analog systems, right? Those 700 different interviews that we've done on more than 25 projects around the world, what we found is in the construction and operational spaces, on average, every electrician on every construction project is spending around 25 to 30 minutes every day to protect their own life through their own due diligence. And that's walking down their breakers, doing their live dead lives, looking through the single lines, confirming that their foremen set everything up for their isolations. And what we found once we introduced our software on these projects is that the average time that they spend validating all of the isolations that they're going to work under that protect their life dropped significantly. Not because we've done anything different. We've just given them that information so much more efficiently. Same thing for essentially onboarding trade partners and requesting lockout tagouts from the SAPs and the APs, right? We've created a digital permit system that'll take roughly a 1 to 2 day turnaround time, which is built into the contracts in North America. We can turn around those digital procedures with digital reviews and digital signatures in less than 30 minutes, from request to an approved procedure that can be executed on a mobile device by a SAP or AP out in the field, right? And then obviously we have our awesome safety. And then finally, working with more than 20 of these construction projects, we figured out exactly what that work hours means in terms of efficiency for how much money they're spending to protect their projects. And we're returning these clients at more than 10 to 1, sometimes even a 21 to return on their investment, depending on how big the project is. And with that, I'll just leave you with some of our client testimonials. Obviously, with NDAs in the data center world, it's extremely hard to talk about some of the clients that we support, but we've done our best to kind of grab some of that information and kind of display it for you. But if we can do this in some of the most complex, large, risky electrical environments in the world with some of these huge AI data clusters and things like that, especially within the next 3 or 4 years, instead of megawatts for data centers, we're going to be referring to them in gigawatts. Especially, like we just had a brand new project come into us that's a 300 megawatt single data center. It has 260 individual medium voltage switchgear and medium voltage transformers in that design for one building. It's pretty insane. But yeah, with that, I'll turn it over my time, and I look forward to talking with any of you guys at lunch.
Good morning, everybody. Right. Just want to talk to you a little bit about PPL. I'm not a sales guy. I'm not marketing. We've got some really good salespeople. We've got really good marketing people. So I do ask the question, what the hell am I doing up here? However, in this arena, I think it's probably appropriate. I am an engineer. I don't consider myself as the training manager so much as somebody that's, I think I'm in my 50th year of employment. So I've been an AP, an AE, a chief engineer, a maintenance manager, an electrician, and so on. So I've been doing this now for around about 14, 15 years. So a bit of a while, yeah. So we are proud sponsors of Scanware. We're very grateful to be here. So yeah, thank you to Scanware at IET building. What a fantastic building. So yeah, we're very keen to be here. So that's us, PPL. I am conscious that every time I turn my head, it goes away from the microphone. We're PPL. And that's me, Graham Taylor, HV Electrical Systems Training Manager. So I deal with all the safe systems of work electrical and a few technical courses that kind of come from that. So we're going to be talking around mainly the kind of things that I do for PPL. So here's what I want to talk about. I've got some good colleagues in marketing. One of the guys that's with me today, and he's done the presentation for me. So I'm hoping I've read it right. I've got a really nice script. If anybody's been on my courses and seen me teaching, they will know that it doesn't take me long to digress. I tend to lose the script after a while. I do tend to sort of just ad-lib. Stick with the topics, but in my fashion. So five reasons why we should, or you should, look at PPL and choose PPL. There's lots of training companies out there, and there's some good ones and some bad ones. It's not for me to say which are which. We put ourselves up against all our competition. So, when we're talking about it, training that your engineers need, and I've lost the script already, so. Strong focus on face-to-face training delivery. We do some on-site training, we do some remote training. There is a demand for it, and in some cases, the application of that is probably the correct one. In most cases, for AP-type training, CP-type training, we need the face-to-face. We need, I think I mentioned yesterday, one of the biggest advantages of being in a classroom is that engagement. Being able to get direct feedback, at the time type feedback. So we do have a strong emphasis on face-to-face training. The practical training exercises and demonstrations. We do quite a lot of PowerPoint or death by PowerPoint. Some of it's necessary to get across the salient points before you even start looking at operation of equipment or switching or anything of that kind. But we realise the importance of getting into the practical areas as soon as possible, because you can lose an audience, I'm sure, within minutes if it soon becomes boring and repetitive. We need that practical training and demonstrations. The main reason why we do have the death by PowerPoint is so that we can cover the why and the when before we cover the how. When we do our courses, our best-selling course, I heard people talking about the rules earlier on, why we haven't got standard rules. We deliver to at least a dozen sets of electrical safety rules. The MOD, the NHS, general commercial for the FM world, for some factories, and so on, which is rather strange when you consider that we are all trying to comply with the same UK laws. But just in slightly different ways and applying it slightly differently. So our best-selling course by far is one that we teach. It's a HV course, a HVAP course, and we teach that with no rules. We may mention and make reference to one or two rules because they're out there and well respected, but we teach it on how to comply with your employer's wishes who are trying to comply with law, but how to comply with law, how to follow the recommendations from the HSE, what the British standards say about certain things, rather than actually your set of rules. We found that people can then go back to work and apply that to their set of rules, and often come back to us to question it, because one of the other things we do, of course, is we've got an engineering services that can write rules for you. So it works quite well, and we have learned that using the no rules method does work quite well. As I say, it is our best-selling course by none. Third-party recognition on all of our electrical training courses. We are City and Guilds assured. And I'll move on because I'll mention that again shortly. Just while it's playing in the background, I'll just try and go back to my notes now because I do have to say a few things while we're doing this. We've got three main centres, one in Livingston, the main centre in York, and Slough. Slough is a fairly mirror image of what we've got in York, but we started in York. And we've got 2 full working HV rings. When we talk about HV rings, it's by what the UK law says HV is. So we don't even talk about MV. We recognise that there's MV out there and people use that term quite a lot. But as far as the law is concerned, which is kind of where we teach from, so anything above 1,000 volts AC is HV. So usually around about 11,000 volts, because that is the most common one for your private networks, and certainly what you'll find on MOD sites, hospitals, data centres, factories, maybe 33. The references that we use, they only go up to 33, I think it is, for the HSG 230, and for the BS662, 636. So up to sort of 33,000 volts. And then, as you can see, with it, as it's scrolling around, we've got lots of equipment in our facilities. When we're talking about that equipment, we've got 4 high voltage rings, 2 in Slough, 2 in York. The high voltage rings are fully working, not at 11,000 volts. We have a control voltage there simulating what would be going on a HV ring. It does enable us to put faults on the system so that we can do fault finding. We've got 2 mock runways for airfield lighting training, low voltage exercises on all 3 locations. And we do all the usual electrotechnical city and guilds courses because we are approved centres. And then point 2. Benefit from decades of experience. Knowledgeable understanding of multiple industries. For my particular section, I've got a team of hopefully soon to be 13 trainers. We cover the UK with those 13 trainers, bulk of which are in York, but we do have 4, soon to be 5 in Slough, 1 permanently in Livingston, and then we also do some of the on-site work. They could come from the York, the Livingston, or the Slough area. What we try to do when we get the trainers is we are interviewing engineers. We're interviewing people that can bring things to us. I'm not particularly looking to hire a trainer at that point. What I want is to hire somebody that can train eventually. Because what we found is we have done this in the past, a few years ago, took on a really good, qualified, very experienced trainer, could not get him to teach engineers. That wasn't his background. So we do need to get people from the background. They do vary. Teaching methodologies and competencies. We understand how people learn. As I say, when I'm interviewing people, where have you worked? What is your background? What are your experiences? Because I know that when they are then teaching others, the questions and the conversations that they will have, that engagement is important. And that comes from telling the stories. Yeah, I've worked here. Well, I worked in that industry. We have a lot of stories. Some are damn boring. One or 2 of the guys I work with, I mean, I can probably pilot a submarine, I'm sure. There's a few. We've got them from the oil industry, MOD, the NHS, say a couple of submariners, wind farms, offshore wind farm. So yeah, we've got them from all industries. My background, I'm from print, agriculture, auto parts, project managing. Yeah, so we've got quite a lot of knowledge out there. So our teaching methodologies, we aim for training for competence. We understand training isn't competence. Hands-on experience in a variety of roles I've been through, understanding the desired attitudes and behaviours required to operate safely. I've had a few conversations, and I used to do it an awful lot myself. Been doing this for 30 years. Been doing this for 25 years. Well, I've been doing things for 50 years now, and until I actually got into training and started dissecting what the law requires of you and that kind of thing, I didn't realise how wrong I'd been doing things for an awful lot of years. So, yes, we never stop learning. I've just been listening to some of my colleagues there. I was quite fascinating. I nearly didn't stand up because I'm listening to what they're trying to tell me. So it doesn't matter what you think, you know, you can always learn something. So behaviours are quite important. And then thirdly, your feedback matters to us. We can be more than just another provider. We do like that conversation. I speak to an awful lot of delegates after courses, their employers, their AEs, in particular their AEs. Training, and I think we've all pretty much agreed that training is only part of that journey to competence. And the AEs are key in making sure that we get the right levels of competence before they're appointed. And we're just part of it. So we can be just more than another provider. Flexibility, personalisation, and delegate focus. We've done quite a few courses in quite a few industries just to their rules, with an emphasis that they want to bring to the table. Sometimes we have to learn that, which is good because it challenges us. We don't like to get too complacent. Are we? Have I had 10 minutes already? Yeah, well, one more minute and I'll finish off for you, thank you. I'll just give you one quick example, because I'm sure they'd want to. We've just done a quick one with Veolia, and just to show that they were quite impressed with what we did. They're doing this particular, what do they call it? Operational Excellence Program for some of their technicians and management, and they wanted an electrical safety management awareness. It was a bit of a challenge to us because it was outside of our comfort zone. We had to draw back on some of our experiences and use some of our soft skills. But they were quite pleased with it. It was just a one-day course. We're hoping to do a bit more with them, and it was well received. Number 4, we address competency. High voltage foundation course. Come and speak to us about our high voltage foundation course. I've heard a lot of people here say training doesn't provide that kind of experience. We've tried to address this to a certain extent. So come and speak to us about our high voltage foundation course. And I'm sure you've seen our mimic system. Come and have a look. Thank you. I'm trying to get you to the next person. Told you I couldn't do it in 10 minutes, David. Yeah. God, I needed 25 minutes, didn't I?
That's why I only had 6 slides.
Ohannes, I think it's your turn. Thank you. Cheers.
Thank you, Graham.
Thank you.
Well, thank you very much, Graham. I will promise to keep it a little bit short. I don't have a problem with that, I think. First of all, thank you very much, Angus and Ben, for organizing the 2-day event and giving us the opportunity to be here. I just want to give you a quick talk about electrical safety journey that we made, about automated electrical accident alarms. This is some information, the next slide, on myself. I'm just going to skip it just to address the more important stuff, so to say. We are Austrian-based company. We are 100% daughter of Omicron Energy, probably known by some of you. Our mission is to develop innovative products that can detect accidents, electrical accidents, fall accidents, and no motion accidents, and then send out an automated alarm. It's all about emergency call systems. There are several on the market. You have manual alarms like SOS buttons you can press, and there's automated alarms. And today I'd like to talk a little bit about electrical accident alarm, also because of a new product that will come to market towards the end of this year. More information you can get afterwards downstairs. Yeah, electrical accident alarm, I already talked about that. As a 100% daughter of Omicron Energy, about 8 years ago, we got the question, is it not possible to develop a product that can detect electrical accident and then automatically switch off the power? Therefore, the picture up here, I think everybody knows it. There's a video of somebody with a sausage. As he comes near to the saw will switch off because there's a sensor inside and detects it, and it avoids for the finger to be cut off. The same thing we wanted to do for electrical accidents, to make sure that if somebody would get into an accident, the power will be cut off really fast. To stop a power source, there's a couple of things you need to do. First, you have to detect if an electrical power source is touched, of course. This we can do through a shirt, a special design shirt, a smart shirt. Second thing is to decide if the incident is also an accident. The third thing would be to trigger a signal to turn off the power source. And final, but it's very important as well, is to call for help to make sure that somebody can be of assistance. It all started like this many years ago. We started designing a shirt. At that time, we had the shirt with integrated smartphone on the shirt, and tried out a lot of things. A lot of different components had to be developed, and of course, it didn't look like the shirt that we have today that I can show you later on if you're interested. But it was important to integrate the electronics in the shirt to make a detection, the detection of the accident. We did a lot of field testing. We tested about like 79, I think even more users, and in a year we collected over 2,500 working days of wearing, and got a lot of feedback. And based on all the feedback and all the experience that we gathered, we developed 2 different kinds of shirts. The first one is the one you see over here. This is the shirt with a short sleeve. It's got integrated electrodes in the upper arms, and they measure the current flowing through your body. And that's also how the electrical accident is going to be detected. After developing this product, and after also having a couple of other products on the market, we discovered there's a lot of demand on the market for arc flash protection, long sleeve. For example, in Switzerland, electricians are not allowed to wear short sleeve shirts. So then we started thinking about developing a product that's going to be arc flash, flame retardant, and also high visibility. And that's how we ended up developing this product, which I have with me. And if you have any questions about it, we can talk about it later on. I already talked about this a little bit. This is like an overview of the shirt, about the certifications that we have now. And yeah, I'm very excited about the product because we know there's a big demand out there. There's many people that are facing, we've been talking about a lot about technical details about avoiding accidents from happening. But as we all know, as long as we as humans are working, the accidents happen. And if an accident happens, then we can make sure that you can get help really, really fast. It's all making the difference between 5 minutes or maybe 5 hours before somebody finds out that you had an accident. Yeah, I just promised to keep it short. This is very short, but I think it's good to stay in our time frame. I want to thank you for your attention, and like I said, if you have any interest and questions, feel free to come to me downstairs afterwards. Thank you very much.
Oh, what a handsome bloke, I hear no one say. Okay, right. Just been watching Angus making dynamic risk assessments as he sees people come up here and go, right, you've got 10 minutes and 10 minutes only. Then Mikko comes on and Angus makes his risk assessment and then brings his timer out. And then we go through, and I'm making a risk assessment saying, right, yeah, do you know what? I'm going to get blamed for being late for lunch. So we're going to crack on now into the PDD Pro. We all make dynamic risk assessments. We all make those judgments every single day. And we all try to keep ourselves safe because we're trying to get home to our families, and that's what makes engineering good. The issue is that technology moves on and things move on. So you used to have a canary in a cage, and now you've got a box of electronics which will keep you safe, or at least give you the heads up that there might be something out there that might be endangering you. So come and have a look at this, come and have a peek, grab yourself some lunch later on, and have a look at what we brought. IPEC, tiny bit, been going nearly 30 years, based in Manchester. It actually is the largest monitor system in the world for HV assets. So it monitors places like London, Hong Kong, it monitors Heathrow, and it monitors other airports, and hopefully we'll start rolling that out to the airports with bigger problems. What you see, though, is you see 30 years of experience which you can have in a handheld. Okay, a little bit of a close-up for it. Let's see what it can do. Big colour screen, easy to read. Multi-language, and it's got your inbuilt TEV and ultrasonics. It records your data, and it also synchronizes the data automatically. And it's dead easy to use with a touch screen, even in gloves. To use it in TEV mode. You're going to put it up against the switchgear, and the sensor will start to detect any TEV activity. And interestingly, it will break it down into PD and noise. A lot of us work in industrial environments where there's huge amounts of noise knocking around, electrical noise. So this will cut it out. This will stop the false positives and allow your engineers really simple, really easy to understand outputs. It can also be attached to a HFCT. We've got a couple upstairs, and that can do your cable PD. Usually it's at a termination or a joint, but actually we can also detect remotely, non-intrusively, whether you've got an emerging issue on your cables. So there's a close-up of the screen. So you've got your PD. You've got the level of real PD there, and not just the background signal. It also does the noise separation. So you can see on the small bits there, you've got the level of noise there. So again, you're being told what is the level of noise in the background and what is the level of PD that you've found. Number of times that I've been to a site and they've said, oh yeah, we've found some PD, we've got this, and actually it's just background noise. And so you're getting more sophisticated. You're making it easier for your technicians, for your engineers, to make judgments about their own safety in a dynamic, risk-assessed way. One of the core things that it does that no other handheld can do is it locks on automatically to the power system, to the power curve. So you get an effective power cycle and you get phase-resolved PD plots, and it builds up like that to a heat map. You can then take a picture of it and you can send it to procurement because they'll make the ultimate decision. But you've found PD, you can illustrate it, you can download it, you can analyze it. You have plenty of options, but really, you look at the screen, two big blobs, 180 degrees apart. Boss, we've got a problem. Right, where is it? Really important that when you get data, you do something with it. So you can save the data. You can push a button, this button here, one button saves the data. You can give it a meaningful name if you want. You can save it to the cloud. You can export it to a smart hub. You can actually send it to IPEC and say, is this PD? What do you think about this? And you can start doing trending on it, all from this little box. Now, we're all sales guys. We're all trying to get you to buy stuff. So, a couple of pieces here. James, he will hire you one of these. Try it before you buy. His details are on our desk if you want to have a go. He likes it, and his clients like it. It's really simple to use. You wouldn't go into a confined space area without a gas monitor, without checking it's safe, without the canary in the cage. Yet, so many of us will wander into a high voltage substation, which no one's been in for 3-6 months, and just wander in there without checking that it's safe first. And this gives you that ability. It also gives you the ability to monitor and check. And the important bit here is the bottom, a 0 result. Now this is a noisy substation. This is in the middle of the Midlands. And a 0 result is a great result. You often feel that engineers, when they go to the doctor and say, I'm really sorry, but you've not got Ebola, they'll go, oh, that was a waste of a test. Actually, a 0 result gives you that confidence that your maintenance is working. So move on. You can leave it for a little while longer. You don't have to go intrusive because there's nothing wrong with it. But you do actually, on occasions, find things which are wrong. And this is very low-level PD. This is very early days PD that Dave has found and posted on LinkedIn. And he found it non-intrusively, both with handheld, and you can see there a permanent, semi-permanent, movable monitor system. You can do something about it when you have the data to support it. You go into your substation, it's live, you do your test to make sure you know what you're walking into. And then you can go and do a very quick survey. Once you've done your survey, then you can assess the data and you can escalate the data and you can actually track and trend the data. And you can find early day problems. And that is an example of one. He now has time to do something about it. He's cleaned it up and yeah, okay, the PD has gone down in severity, but it's going to come back. So he now can, and this is one of his top 200 critical substations, so he can do something about it. Okay, it's lunchtime. I've pulled a bit of time back, but please, come and have a chat. We do like talking, don't we? And we do like having people come to our stands, and actually we do like engineers. There is a special offer coming on. Free beer pump with every one of these, because it is the summer. Please use this in a substation. Take that home. Thank you very much.